The last time we took notes, we looked at the product and quotient properties of powers, multiplying and dividing exponents, essentially. But today we're going to look at some more exponent properties, a few more things that you need to watch out for when multiplying or dividing monomials. So first, we're going to look at what's called the power to a power rule. And so it says when taking a power to a power, you multiply the exponents. Apply the power to the coefficient normally. So when we multiplied powers in the previous notes, 3.1, you multiplied the coefficients and added the exponents. And remember, a power, an exponent, is just a shortcut to repeated multiplication. And that's essentially what's happening here. What we're showing is that when you take a power to another exponent, instead of writing it all out and doing the regular product property, you can take a little shortcut and just multiply the exponents. And I'll show you what I mean by that here. So if we have 2g cubed all to the fourth power, so this whole thing is being taken to the fourth power. What that essentially means is you have 2g cubed 4 times. And if we were going to use the product property as normal, we would do 2 times 2 times 2 times 2, which is 16. And again, the shortcut there is to just do 2 to the fourth power. So we apply that exponent to the 2 to the fourth. Now for the g to the third, we have those 4 times. And remember from the product property, we just add those together. 3 plus 3 plus 3 plus 3. Which is 12. And that's where we get that g to the 12th there. Okay, so the shortcut then is to, instead of doing 3 plus 3 plus 3 plus 3, we can just do 3 times 4. Okay, because remember, exponents are just repeated multiplication. So if you remember the rule, kind of the shortcut, apply the exponent to the coefficient as normal, 2 to the fourth power, and then you can just multiply the exponents on the variable. Or you can expand it out. Especially if it's just a smaller one like 4, like we did here, you can write it out 4 times. Now the next rule is the zero exponent rule. Anything to the 0 power is 1. So for example, g to the 0, x to the 0, both of those just equal 1. Negative exponent rule. This one gets tricky. And there's a few different ways to think about when this shows up in operations when you're actually doing practice problems, and we'll talk about those. But essentially a negative exponent indicates a reciprocal. You need to move it to the other side of the fraction bar. So g to the negative third, that's 1 over g to the third. So you just move that g to the third to the other side of the fraction bar. Now if it was already on the bottom, let's say it was 1 over g to the negative third, you'd have to still move it to the other side. That would be g to the third over 1, or just g to the third. Right, so when that comes up, that is kind of what you have to do with it. Now if you are in the middle of multiplying or dividing powers, you can use the negative exponent and do the operation. So if you're multiplying powers, you can add the negative exponent. If you're dividing powers, you can subtract the negative exponent. But in your final simplified answer, you should have no negatives. Those need to be taken care of and simplified out. All right, let's do some examples, and hopefully these will make a little more sense. So we have x to the 5th all to the 2nd power. And we just need to multiply those exponents together. So that's x to the 10th. And remember, you could write this out as x to the 5th twice. Right? That's what that 2 means. So you have 5 x's, 5 more x's, that's 10 x's total. Example B, very similar, 3 times 2 here, that's y to the 6th. Example C says 5 times negative x to the 0 power. Now this exponent is just being applied here to this negative x. The 5 is not in those parentheses. So we know that anything to the 0 power is 1. And so we essentially here have 5 times 1. That's just 5. Maybe a little tricky here on this fourth one, example D, with the fraction being taken to the 3rd power. But we just have to remember that the exponent gets applied to the coefficient normally. So you can think of this as 3 negative 3/4 w's. And we're going to take negative 3/4 times itself 3 times. Okay, so I would recommend you just go piece by piece here. So a negative times a negative times a negative, that's a negative. And then to multiply fractions, just multiply straight across. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 4 times 4 times 4. 4 times 4 is 16. 16 times 4, that's 64. And now we do the w's. Well, just add them up. You've got 1, 2, 3 w's. That's w to the 3rd. Now, to avoid writing all that stuff down and taking that long, you could just apply the exponent to each thing appropriately. So negative 3/4 to the 3rd. Do the same thing we did, we just don't need to write it down. And then w, there's a 1 here. You can multiply 1 times 3. So remember to apply that exponent to the coefficient normally, but you can just multiply the exponents together on the variable. And you should check and see if you can simplify this, but 27 and 64 don't share any factors, so that is simplified. Example E, we have h to the 3rd to the 2nd to the 2nd. Now these kind of nested power problems are very common, and they look kind of confusing, but just remember, especially if there's no coefficient here in front of h, we're just multiplying 3 times 2 times 2, and that is h to the 12th. 3 times 2 is 4, 3 times 2 is 6, 6 times 2 is 12. Example F, a lot going on in this problem. Very easy to look at this and be overwhelmed. I would recommend you just start simple. Start with something that you see that you know how to simplify. For example, this first parentheses, 3 to the 3rd power, that's 27. 3 times 3 times 3, be careful, it's not 9. 3 times 3 is 9, 9 times 3 is 27. These, however, we can multiply 2 times 3, that is 6. Still over 6m to the 4th, and we're going to multiply by the stuff over here. Now let's do the same thing. Let's simplify 4 to the 2nd power, that's 16, 4 times 4. And then you can just multiply 3 times 2 for the m, that's 6. 6 to the 2nd power, that's 36. And then you can multiply the exponents, k to the 4th. Well, now we have some simplifying to do. Now we could multiply straight across. 27 times 16, 6 times 36. That'll work just fine. Let's go ahead and do it that way, and then there is another method you can use. So 27 times 16, I'm not going to try to do that in my head. That is 432. And then for k and m, they don't share a base. So k to the 6th, m to the 6th. Over 6 times 36, that is 216. Again, m and k, k to the 4th, m to the 4th. Now we have to simplify this fraction. So remember, divide the coefficients and subtract the exponents. So 432 divided by 216. That's 2. And then we can subtract the exponents. On k, 6 minus 4, that's 2. And on m, 6 minus 4, also 2. Now, if we had noticed, or if this is a method you prefer, before we multiply these red fractions here, we could do some cross-canceling. 27 and 36, for example. Well, 27 and 6 both share a factor of 3, so you can divide those by 3. Okay, 16 and 2, because everything's being multiplied, we can do this. 16 and 2 share a factor of 2. 9 and 36 can both be divided by 9. And then 8 and 4, that's 2. So we can simplify all that down to a 2 before we even do any multiplying. And then, since it's all being multiplied together, you know you're going to subtract this 6 and this 4. Same thing with this 6 and this 4. So if you're able to, you can simplify these like that. And maybe it's a little easier, but it's also kind of messy. So if you like to do what we did in the first place and just multiply straight across and then simplify, just as easy with a calculator, so no worries on that. Whichever method you like to work with, it's all fine. Get the same answer either way. Okay, example G, back to just multiplying. However, we do have exponents. This first parentheses has a 2, and this one has a 3. So we need to do that first. 4 to the second power is 16, and then multiply the exponent, so x squared y squared, times, now negative 3 to the third power, that's negative 3 times negative 3 times negative 3. That's negative 27. Multiply the exponents, d to the 6th. And now we need to multiply 16 times negative 27, which gives us negative 432. I guess I could have known that from the previous problem. And then we have no powers that share a base, so just write them out. D to the 6th, x squared, y squared. Example H, we have a negative exponent. Remember, that means it goes on the other side of a fraction bar. So this is just y over x squared. Just move the x squared down, take the negative off, leave the y on top. All right, example I here. We'll get there. There we go. Okay, so a little complicated. Whenever you have a big fraction power like this, all to an exponent, I would recommend you simplify the inside first as much as you can. So 3/4, we can leave that alone. That's already simplified. For x, we have 7 minus 6. So that's 1, x to the first power. For y, now see the 12 was on the bottom. So 3 minus 12, that's negative 9. So we know that that 9, y to the 9th, is going to go on the bottom. You can also remember that 3, 4, 5, 6. What this is happening is 3 of these y's cancel out from the top, and you're left with 9 on the bottom. So that's another kind of visual reasoning for why we end up with the negative 9, which goes to the bottom. 3 minus 12 is negative 9. So it needs to go on the bottom of the fraction. And also, because 3 y's from the top cancel out 3 from the bottom, but those 9 that are left, they have to stay where they are. And now 7 minus 7 for z, that is just 0. So the z's go away, because anything to the 0 power is 1. So we just have a 1 there, so you don't need to write it. So this is what's being taken to the third power now. So just apply the exponent normally to each thing. 3 to the third power, that's 27. 3 times 3 times 3. And then 1 times 3 for x is just 3. For the bottom, 4 to the third power, that's 4 times 4 times 4. So that's 64. And then 9 times 3 for the exponents, that is 27. So 27x to the third over 64y to the 27th. Kind of a weird looking fraction, but that is as simple as it can get. We have simplified as much as we can. All right, example J, similar. We just don't have a big exponent, so we can just simplify this and be done. 24 over 36, we can reduce that by 12. That's 2/3. I kind of, this first step, I like to just extend the fraction bar a little bit, fill in what I know, and then I can make it look better afterwards. So for x, we have 5 minus 8. That's a -3. That goes in the bottom. Or you can just think wherever the bigger one is, so on the bottom we have 8, that's where the answer will end up. 8 minus 5 is 3, so we have x to the third down here. And then for y, same thing, 10 minus 4, but the 10 is in the bottom, so y to the 6th. And you can leave it like this, or if you're picky about it, you can move the 2 to the middle so it looks a little cleaner, just like that. Okay, example K, very, very similar. 75 over 15, or -15, that is a -5. And depending on where the rest of these end up, we may have to add a fraction bar, but we'll see. All right, for P, we have 5 minus 3, 5's in the bottom, so we do need a fraction bar. So we have P to the second power on the bottom, because 5 minus 3 is 2. For the Q's here, it's going to get a little complicated. We have two negatives, and you can just do straight subtraction. -5 minus -4, that's -1. So we have a Q to the first power on the bottom. Or if you want to think about it like this, both of those are just going to switch places. So Q to the fourth on top, Q to the fifth on the bottom. 5 minus 4 is 1, so it stays on the bottom. You know, whatever order you decide to think of that in your head is fine, as long as you end up with Q to the first power on the bottom of the fraction. And now this r to the -8 just needs to go up top, r to the 8th, just like that. So we have -5 r to the 8th all over p squared q. Okay, last one here, example L. Now we have an exponent, but it is a negative. So again, like I said before, I recommend you simplify the inside as much as you can, and then we'll apply the negative, or the exponent. And because it's negative, I will help you figure out how to do that in the best way. So let's start by simplifying the inside. 5 over 15, that's 1/3. 15 divided by 5 is 3, but since the bigger one's on the bottom, that's where the 3 needs to go. And I'm leaving a 1 just because you shouldn't leave the top of a fraction empty, and I can always erase that 1 if there's something else that we put up there. All right, so for B, we have -2 minus 5. Or you can think these, since this is a negative, they're going to go down here and join the 5 on the bottom. Either way, we get -7 or b to the 7th down here. And then for n, 4 minus 2 is 2. So we have n to the second power on top. And I'm just going to turn this 1 into an n so I don't have to write like that. Okay, and now we have the exponent -2. So here's what I recommend when this whole thing is a negative. First of all, the negative sign is going to flip everything inside. So instead of trying to multiply everything by -2 and then flip it, then move them, just use that negative sign to know that you're going to have a reciprocal. So 3b to the 7th over n squared, and then it's just all to the second power. So that's the easiest way that I can come up with to try to have you do this problem. Because if you try to multiply the exponents by -2 and take the 3 to the -2 power, there's more opportunities to make mistakes. But if you just use that negative sign to flip your fraction and then apply the 2, it makes it a little easier. So 3 to the second power, 3 times 3 is 9. And then we can multiply the exponents. 7 times 2 for b is 14. 2 times 2 for n is 4. So 9b to the 14th all over n to the 4th. Okay, so to just quickly recap the 3 new rules. Power to a power. Apply the exponent to any coefficients normally, and then multiply the exponents. Zero exponent rule, anything to the 0 power is 1, and negative exponents indicate a reciprocal, so just move that term, that power, to the other side of the fraction bar, but keep the number the same. Just take the negative off.